I'm a Yanghee Kim, the workshop organizer. I'm an educator. So when I first have this new tool, my question is, what? Why robots? What this robot can offer for children's learning and development uniquely, other tools cannot. My research on social robots and children would be still, the research journey to explore educational potential of this new tool. My talk is more, very detailed educational perspectives, but listening to Cynthia's talk, you will see the recurring themes between our presentations, and then my project actually exemplify her argument. This was my ever first project using robot. I was contacted by a robot manufacturer, and they had this new tool, and then asked me, and what kind of learning applications can be run through using the technological features of the robot. And their target market was Asia and Europe. Those countries where many children learn English as a second language. So the target learner group was 7 to 8-year-old ESL children. And the topic was early English literacy skills. And then I designed for one-on-one interaction. This is a 3-minute video overviewing the project. But while watching this video, I want you to think about affordances. What unique interactions can be created because of technical features of this robot?
Last 3 decades, the number of American children whose home language is not English has almost tripled. The U.S. Department of Education expects that the number will continue to increase to 40% of the K-12 school-age population by 2030. ELL children enter kindergarten behind in English proficiency, which contributes to lower achievement in all academic disciplines. Early intervention supporting this group's academic development is essential, and technology can play an important role. The DEAR project develops English language and literacy applications run via an embodied toy robot for young children aged 4 to 7 whose home language is one other than English. Research presents that young children, regardless of their cultural backgrounds, naturally develop affinity to digital toys and devices. We used a robot system combined with a smartphone. The phone is cradled on the robot's head, and the robot is equipped with optical, touch, and proximity sensors and controlled by Android apps via Bluetooth. It moves around and expresses emotions using LED lights. The key principles that guided our development include: children learn while they play with others. Children develop cognitively by engaging in haptic and kinesthetic activities. Children develop socially and intellectually through repeated participation. The robot's advanced sensors interact with printed cards and a book. One episode includes songs, games, and book reading. In this episode, children learn names of colors, names of geometric shapes, and letter sound match. The robot sings. Circle, circle, circle. Children play games with the robot. The robot reads a book and children play an I Spy game to the robot's cues. During our user testing, we observed that the robot had to repeat the word several times to get the child to say the word. Providing different interaction options was essential for children to take ownership of the activities and to their voluntary engagement. Lastly, the user testing revealed that children moved around while enjoying parallel play with the robot. Diverse expertise in our team was crucial to the success of the project. Our design team included 4.
This is the very first project. So, and then, as Cynthia mentioned, initially, pretty new to this project, immediately we expected one-on-one interactions. But through our user testing observations, many children love to work with a friend. So, at the end of the project, why not design this as a social plaza, inviting children's collaboration. And so that leads to our next project, the project idea supported by NSF Cyber Learning. And here we proposed to create a small socio-technical learning community between a robot and two children. And target learners were kindergarteners, native English-speaking and English learning children. So one children has a Latino-speaking background, and then the other children from English-speaking background. And robot, we suggested if a robot can mediate these two groups of children's collaboration. So we designed a robot as a bilingual, speaking Spanish and English, and then a culturally brokering friend. Given this idea was the first question, what does it mean, cultural mediation? So as Cynthia mentioned, the nature of this study, robot and children, just the scale of theoretical backups we have to build was just, very huge. So you see early childhood development theories, and then multicultural education, and then plus intercultural communications, and then identity theory, and then the positioning theory. And then this is only for educational side of theories, and then without considering all technical part, engineering side of the project. We spend whole semester, 5 people, whole semester, diligently reading through all the representative literature from each domain. And then we created this theoretical model to help us design robot-children collaboration. So the collaboration goals include building common ground and equitable partnership, and thirdly, co-cultural schemes. And then what the robot's brokering strategy is represented with invitation, opportunity, and empathy. So given this theoretical framework, we started with human mediator. Human mediator, it was a College of Education speaking both Spanish and English. And then we gave this, ask this human mediator to do her best to make children collaborate. And I'm not sure you guys have young children about that age. If you put your children in preschool or kindergarten, and typically what happens is that kindergarten classrooms are run by stations. So one station have 4 to 5 children with one teacher, tutor, volunteer, or teacher. Then when they come, this teacher gives children a worksheet or a task. And all they do is they finish, children, even though they are in the group, they just finish their work individually, and whoever finish first, they can have free time. So even though it is a small group and classroom setting, children are not trained to work together. So it was very kind of challenging to us, make children work together, talk together while performing tasks without talking to the teacher. So we experimented with this human mediated collaboration session about 7 weeks. And we scripted their dialogue first, and then used their scripted dialogue to start implement to robot, and robot start actually a very basic set of prescribed statement utterances to promote their collaboration. So each session took about 15 minutes on popular topics, animals and birthdays and schools and the family issues. The key design challenge for us was, first issue was language of kindergarteners is still developing. And how can we cope with the technologically this? So we adopt a Wizard of Oz method. And the Wizard of Oz method is pretty popular software engineering technique. So when technology doesn't have a full function as designed, the missing component is replaced performed by a researcher hidden from the scene. So children think they are interacting with a robot, but actually robot is controlled by researcher behind the scene. So, and then second challenge was children respond best to a casual, kind, yet direct manner of communication. So we designed the robot talk same messages repeatedly until, if it doesn't hear any children's utterances, and then try to make a conversation explicit as possible, even very directive. Children's behavioral patterns are often difficult to predict. So we designed the episode, each session we named the episode, rather than expect children behave a certain way, but rather we just design the scenario, let the children bring in their own topic. So, and then lastly, children have a short attention span. So longest session we had was 20 minutes. But actually, after 20 minutes, our problem was children did not want to leave. Previous project, we designed for 20 minutes, but children wanted to repeat over and over. So sometimes, because we couldn't just let them go, so we just let them play more than hour, but they just don't want to go. So again, supporting Cynthia's argument about children's engagement, affection, and they have with the robot. To support the children's exploration in their thinking and talk, we introduced the Scusi, name of the robot, as a newbie from another planet. So the Scusi has to learn every aspect of a life on Earth, and spoke both Spanish and English at a random manner. So even his English and Spanish was not perfect, make mistakes. So like children have to make up the Scusi's mistakes. And we visited the kindergarten and worked with 12 pairs of children for 4 months last spring. And again, as Cynthia mentioned, we have to continuously design, repeat design iteration. So start with the basic scripts derived from human mediator, and then as we move, when children bring up a new statement, next session we added more script, robots utterances. One semester implementation, we have made some key findings here I want to share with you. So these findings is very consistent with Cynthia's point, the point Cynthia made. So children developed very affectionate relationship with the Scusi. So as we implement, every session, it was a great surprise to me. Wow, I never expected it that way. Because we all adult mind, we knew our robot has many technical and functional limitations. And even a researcher sitting behind me, I made mistakes a lot. So I pressed the wrong button and the robot behaved strangely. So we found the children I was very embarrassed, and my team was so embarrassed when that happened. But children were just finding it fun. And they don't even care. Because, so look at this, during the school, the conversation, they just came to schools and hug it. I love it. And next one, very engaged with the Scusi. So how to present engagement with visual images. I didn't have a IRB permission to present their videos. So yeah, it was, about to finish the session, they didn't want to leave. And they keep asking, children keep asking Scusi on, relevant questions, probably, try to drag and try to stay longer as best as they can. So Scusi coming with us, how can he go to home? Like after this, like they were very concerned about Scusi, and they just want to stay longer with the Scusi. And their interaction with the Scusi is a friend, friend-like. So I let's listen to this conversation in this session.
I don't know what we can do for my friend's birthday.
You can, what?
Can we do this on my friend's birthday?
No, you can't go shopping. He's crazy. He's crazy.
Nicole, why not?
Because that's not.
So why on the screen on Scusi's head there is a picture. So Scusi talks and have the visual materials to present.
How you play with friends. You go in a fun place, like a jumpy house. Yeah, or jump sums.
Okay. When would we go to supermarket?
With your mom and dad.
Scusi asked when do we go to supermarket and children with mom and dad. So their conversation doesn't flow as we expected. So that's why it gives hard time to speech guys working on speech technology. Children are very forgiving of robots' mistakes because of me and because of technical limitation. But Scusi, look at this. Scusi moved and stopped suddenly and then make awkward mistakes. But I was pretty interesting to see their comment. Scusi's robot, Scusi doesn't even know about eating yet, because we didn't prepare scripts related to eating when children asked, "What do you eat?" And then, what? I don't. And we have a script. I do not understand. I'm confused. So, and then children make up Scusi's gap. Yeah, children even know. Scusi doesn't even know about eating yet. Because he's from different planet. Making children work together, not to talking to Scusi directly, was pretty challenging at first, because the children talk to Scusi as if they don't have a partner at the beginning. And we used this strategy whenever they talk at the same time and talk different messages, and Scusi talked to, like, I'm confused. Can you talk one at a time? And if you say two different things, I do not understand. So talk together, because remember, the goal of this session was to let children work together. We started the implementation from February, and then close to May, we saw when Scusi threw a question, children started talking. And they learned Scusi cannot, understand if they say different thing, give a different information. So children gradually started talking together. Going back to my original questions, affordances, the robot's mediation over human mediation. So we used the human mediation just to help us start building robot-mediated interaction activities, but actually through data collection, we found, we transcribed all their interactions, and we found we had 46 video clips, each 15 minutes long, And throughout the session, we spotted 79 times children's distracted. And then or 65 of them happened in human-mediated interaction sessions. So we implemented the human session 7 weeks and the robot-based session 8 weeks. But actually, during the robot-mediated section, we spotted only 13 distractions by children. So again, supporting all the arguments Cynthia made. So this year, it was the project started last year, and last spring was January 1st last year. So last spring was quick design and implementation of what we can do with this in terms of robots brokering. And then this year, we are expanding episode to be long. So earlier intervention was all verbal conversational, but this time we want children make something together, create artifacting together as mediated by a robot. And then we are integrating curricular content, early literacy and mathematical concepts. That's our plan this year. And we want to observe changes in children's engagement and collaboration skills. Earlier one didn't specifically examine, we didn't collect data systematically to examine these two outcomes. And so given this goal, I love to have people, people here working on the computational models to assess children's engagement and collaboration skills development using visual data and speech data. And I love to work with experts in dialogue generation so we can automate children's interaction with a robot.